Hi, good day students. Welcome to our chemistry lesson 2. So today I'm going to do with you all on carbon compounds. So for today's class I'm going to focus to you. I'm going to give you a little bit of techniques to answer paper 2 questions and even paper 1 questions regarding carbon compounds. So before we further up on our today's lesson, let me tell you briefly what are the parts you have to be focused in this particular topic. Usually what students have to know in carbon compounds is regarding the definitions. Okay, there are certain terms are involved in these carbon compounds. You have to be well versed in explaining the terms. Secondly, students must know all the general formula, functional group, and also the naming the compounds and drawing the compounds for all the 6 homologous series can be found in the carbon compounds. And you must be well versed in defining what is isomers and isomerism, and you should be able to draw and name the respective compound for isomers. And then there are certain chemical reactions involved in carbon compound, especially please focus on the experiment on dehydration and esterification, and you also must know how to draw the setup for dehydration. And beside that, upon completing all the 6 homologous series and their chemical reactions, so students must be able to analyze the chemical reaction and use these chemical reactions to differentiate the solution given to you. Okay, this is considered a higher order thinking skills will be applied when you're answering this type of questions. So today I'm going to explain to you about each and every things I have shared with you now. Okay, as I told you just now, for this topic you have to be well versed in defining the terms. Okay, let's look at the terms that have been used in this carbon compounds. Firstly, there's a term on hydrocarbon. Okay, students, you have to define the term hydrocarbon correctly. They're very important here. When you define, there are keywords to be applied. Especially when hydrocarbon, you have to say compound consists of hydrogen atoms and carbon atoms only. The word only is very important. Okay, so how can you remember on this term? Can you split the word hydrocarbon to hydro and carbon? So remember, hydro is hydrogen and carbon. So hydrocarbon is a compound consists of 2 atoms. What are the 2 atoms? Carbon atoms and hydrogen atoms only. Okay, so that's the definition for hydrocarbon. When come to saturated, can you see the word satu? Okay, satu means is single. Remember, okay. So how can we define on saturated hydrocarbon is, you define your hydrocarbon first as usual. Compounds consist of hydrogen atoms and carbon atoms. Okay, now we want to define on saturated. So how we define the saturated? Remember the word satu, single. So that means where the carbon atoms are held together by single bond only. Okay, these are the keywords. Remember, yeah. For saturated hydrocarbon, compound that consists hydrogen atoms and carbon atoms, where the carbon atoms are held together by single bonds only. Whereas when it comes to unsaturated, un means not. Okay, it's not a single bond anymore. That means it consists at least 1 double or triple bond between the carbon atoms. Okay, so students always getting confused between saturated and unsaturated. So here I've given you a clue. So remember, satu means saturated, single bond only. But when it comes to unsaturated, that means it's no longer single. It consists at least 1 double or triple bond between the carbon atoms. And what is the meaning of isomers? Okay, isomers means the molecules that have same molecular formula but different structural formula. Okay, these 2 are the keyword. They must have a same molecular formula, different structural formula. Okay, now if they are talking about isomers, we will mention it as molecules. There's another term also will be used, that is called isomerism. When the question comes out on isomerism, then please substitute the word molecule with phenomena. Okay. Now, when we talk about isomerism, that means we are talking about the phenomena where the molecules having same molecular formulas and different structural formula. So most of the time students get confused with these two terms of isomers and isomerism. Isomerism is we are talking about the phenomena where the molecules tend to have the same molecular formula but different structural formula. But when we are talking about isomers, we are particularly pointing to the molecules exactly. Okay, so these are the four common definitions will be questionable for your paper 2 to define. Okay, beside defining, students must be well versed in writing the homologous series, general formula, and the functional group of all the homologous series of the carbon compounds. So now, let's recall back what you have studied in carbon compounds. There are 6 homologous series actually involved, which are: first, you learn about alkene; second, you learn on alkene; third, you learn on alkyne; fourth will be alcohol; fifth is carboxylic acid, and sixth is the ester. Okay, in this 6 homologous series, okay, always students get confused when the question come out on homologous series. They don't know what they actually wanted. Homologous series means the name of family. This is for your own reference here. Okay, so you must know when you see the word homologous series, what should come to your mind is the name of the family of the carbon compounds. So we have learned 6 carbon compounds families here, which are alkene, alkene, alkyne, alcohol, carboxylic acid, and ester. Okay, the second important thing that you should know is their respective general formula. Each and every homologous series have their own general formulas. The general formulas is very important. Make sure you get the general formula right. If you made any mistake to your general formula, it will affect your molecular formula writing and also naming the compounds. Okay, now for general formula for alkane is CnH2n plus 2. If the question comes out on right top on the general formula, what I advise is you just enclose this CnH2n plus 2. No need to write the value of n. But you as a chemistry student, you should know the value of n must start with 1, 2, and so on for alkane. Whereas for alkane, minimum required 2. So it starts with carbon 2, 3, 4, and so on. And for alkyne, also the same, because for them to form a triple bond, they need minimum of 2 carbons. They don't have 1 carbon here, and so on. Okay. And when it comes to alcohol, N can start with 1, 2, 3, and so on. And when it comes to carboxylic acid, remember, because at the tail part here already have 1 carbon, so the value of N will start with 0. Okay, so these are the parts you have to be clear of. But when write up the answer for general formula, try to write the basic one, the CnH2n what. No need to enclose the value of N, because the value of N is not required in writing the general formula. If you are wrongly substitute the number, then it will affect your marks. So better don't take the risk. So remember, alkane, general formula is CnH2n plus 2. Alkene is CnH2n. Alkyne, opposite to alkane. Alkane plus 2, alkyne must minus 2. Okay. Alcohol will be CnH2n plus 1 OH. Carboxylic acid CnH2n plus 1 COOH. And the combination between alcohol and carboxylic acid will derive the molecular formula, general formula for the ester. Now, what is functional group? Functional group is like an ID. That the ID will helps you to determine the compound belongs to which homologous series. So for alkene, the identity that we hold on is the carbon-carbon single bond. When you see all the carbons are linked by single bond and only made up of carbon and hydrogen atoms only, then we know the compound belongs to alkene. So in that sense, carbon-carbon single bond becomes the ID for the alkene family. Whereas for alkene, If you find any double bond exists between the carbons, then that compound belongs to alkene. So carbon-carbon double bond is the functional group for the alkene, whereas for alkyne is carbon-carbon triple bond. Okay. Now, when it comes to alcohol, the functional group is known as hydroxyl group. Carboxylic acid, carboxyl group. Ester is called carboxylic group. Okay, there are three ways actually you can state your functional group. Either you spell out the name, or you can just write it in a form of formulas, or you draw it. Okay, when it comes to this part, you have to be a little careful. Okay, so now I want to focus to you about draw. If the question asks you to draw this functional group, then how do you go about it? Okay, that's it. The question asks you draw the functional group. Group, let's say for alcohol. So when they ask you to draw the functional group, or they ask you to show the structural formula for the functional group, so how you do is, remember, you start with one carbon will have 4 bonds, right? So you can put your O over here and then H. That shows the structural formula of functional group. The location of the OH is not necessarily supposed to be here, but I will always recommend my students to place it towards the end, so you are in the safe side. If let's say you are intend to draw it on top or at the bottom, what you have to be careful about is the location of the O. Remember, when you place the OH, O must always directly facing the carbon and H is right beside the O. Okay, either you are placing it on top or at the bottom, it works the same way. When I put the O here, then my H must be beside it, and make sure each carbon will have the 4 bond there. And another way is some students, they tend to put it in front. Okay, when you are planning to put it in front, as I told you, always bear in your mind, O must come first. O is directly bound to your carbon, and beside the O you will place the H. Okay, so this is the correct order of placing your hydroxyl group to show the bonding how it occurs. Okay, now when it comes to carboxylic acid, how we draw the functional group is, you put your carbon, okay, draw double bond. The double bond must be with O, and another one will be OH. So this is what shows the structural formula for the functional group for carboxylic acid. And another one is for ester. If for ester, it will be same as this. You only have to eliminate out the H from the carboxylic acid. Okay, because carboxylic acid is COO only. We don't place the H. So this is how we show the functional group of each homologous series of alcohol, carboxylic acid and ester by drawing it. So when it comes to functional groups, students, please be careful on the requirement of the questions. Either they ask you to name or draw or state. If they ask you to name, then you just mention the name fully. Spell out hydroxyl group. Carboxylic acid will be carboxyl group. Ester will be carboxylate group. You have to spell it out. If they ask you to draw, then this is the answer should be as what I show you here. Okay, if they ask you to state, then it's optional. You want to write the name, or you want to draw, or you just write the formula also. Okay, so just now we saw on the terms and also the homologous series, right? Now you have to interrelate the terms with the homologous series you have learned. Okay, generally the first thing will be carbon compound. Now, what is carbon compound? Compound consists of carbon as their constituent element. Whenever there's a presence of carbon element inside it, regardless is combined with whatever element also, we call it as carbon compound. And this carbon compound had been split into 2 categories here. One is called organic carbon compound, and another one is called inorganic carbon compounds. Okay, how we classify whether it's organic or inorganic? From the source where we obtain. If you are obtaining the carbon compound from living things, then the compound is considered as organic carbon compound. If you are obtaining the carbon compound from non-living things, then the carbon compound is considered as inorganic carbon compound. Okay, now we're going to focus on organic compounds. All organic carbon compounds can be split into two categories. Which are called hydrocarbon and non-hydrocarbon. Okay. And here is where you have to be very careful. Hydrocarbon can be split again into two, which are known as saturated and unsaturated. So all the 6 homologous series you have learned, you should be able to fit them into this classification. Yeah. Okay. So when we are talking about saturated hydrocarbon, there's only one homologous series comes here, that is alkene. Remember what is saturated hydrocarbon? That means consists of carbon atom and hydrogen atoms only, where the carbons are bound with single bonds. When come to hydrocarbon which are unsaturated, then it will be 2 homologous series. There's a 2 possibilities. Is either can be alkene or alkyne. That means the carbon compounds consist of carbon atoms and hydrogen atoms only, where the carbon atoms consist at least 1 double or triple bond. Okay, then it comes under unsaturated hydrocarbons. When it comes to non-hydrocarbons, then there will be 3 homologous series goes inside here. Okay, non-hydrocarbons, it can be either alcohol, carboxylic acid, or ester. Okay, so when come to the term and the homologous series, you should know where this homologous series are fitting in. Okay, this is a general map for your carbon compounds and their homologous series. So now let's apply what you have learned in answering the questions now. So let's look at this first question. Which of the following is the structural formula and unsaturated hydrocarbon? From the word unsaturated, you should know already the carbons must consist at least minimum 1 double or triple bond. Hydrocarbon must consist of hydrogen and carbons only. So by looking at the structure, you should know already this is rejected because of Cl, and this one is rejected because of the presence of O, right? So right now we have 2 possibilities. The answer can be A or D, because A and D are hydrocarbons, but now we have to go and look for unsaturated. You have to look at the carbon bondings, which one consists of double bond or triple bond. So with that, A will be the answer. So now let's look at the second question. Which compound is a saturated hydrocarbon? If you look here, students, the compound is not shown, but they have given you the name, right? So again, we go back to your understanding of the concept. Hydrocarbon, saturated hydrocarbon. If you look back to the map I shared with you just now, there's only one homologous series comes under this category, which is alkene. And for the rule for naming, you should know the name of all the members must end up with A and E. So whatever compounds end up with A and E, they are the members in the homologous series of alkene. Okay, now let's look at this. Propene is alkene, so it's unsaturated, now saturated, yeah, so it's rejected. Now propane, can you see the A? So that means this propane is a member in a homologous series of alkene. So the answer will be B. Proper noun is alcohol. Okay, this is an example of question came out in paper 2. So what they have done is they have shown the structural formula for a carbon compound X, and then they ask you to state the meaning of carbon compounds. Okay, the requirement here, they are asking you to state what is carbon compound. So what is carbon compound? Compound that contains carbon as their constituent element. Now, let's look at this question now. Propane and propene are members of different homologous series. Which of the following is a general formula of the representing two compounds? So as I told you, what the first analyzing you have to do is, you have to analyze the question. Propane come from alkane. Propane come from alkene. So you must know alkane, the general formula of it will be CnH2n plus 2, whereas alkene will be CnH2n. So please go and look for the respective answer. So what you'll get is the answer will be B. So most of the time when it comes to this type of questions, students get confused. They will mix match the formulas and so on. So please do the analyzing correctly and go and look forward for the respective answers and answer it carefully. Don't do any careless mistakes. Okay, now let's look at this question. State the homologous series of compound X. Okay, students, again I'm telling you, the moment you see the word homologous series, your answer must be the name of the family. Name of the family means either alkene, alkene, alkyne, alcohol, carboxylic acid or ester. Okay, so for you to determine the homologous series, what you have to look is, go and look for functional group, the ID, the identity of the group. Okay, as you can see here, you know already there's a O. When there is a O, it should be non-hydrocarbon compounds. So if you still remember the map I shared with you just now, non-hydrocarbon, there are three families: alcohol, carboxylic acid and ester. So now let's look at alcohol. Alcohol, the functional group must have OH. Carboxylic acid must have C double bond O. Do they have C double bond O? None. And carboxylic for the ester also C double bond O. None. So what the functional group present here is the OH. So the moment you see the OH, you should know already this compound is alcohol. So when they say state, so you go and write alcohol. If let's say the student go and write negative OH, then your answer will be wrong, because they want the name of the family, not negative OH. So this is the misinterpretation always occurs among the candidates, because they don't understand the word homologous series. So what I'm going to emphasize here is homologous series, name of the family, remember. Okay, now let's look at this question now. State the functional group. Can you see the word functional group of compound X? Okay, let's go to the structure, look at it. So where's the functional group? Functional group is the idea. Okay, can you see this? C double bond OOH. So C double bond OH is actually what? Carboxylic acid, right? That carboxylic acid is homologous series, but they want the functional group. So the question asks you to state. So it's your optional. If you're not sure, when the question gives you state, you just copy back what you see here. C double bond OOH. You will get correct. Okay, because the question is state. Or if you're sure, then you can spell out carboxyl group. If the option given for you to name, then you have to spell out like this. Or you also can write COOH. This is also considered correct. So these are the three methods of answering when the question asks you to state for function group. Okay, now let's try out to answer this question. Again, go and analyze the question, get the keyword. They want the homologous series for compound J and K. So now let's look at compound J. we know it only consists of carbon and hydrogen. That means this is only a hydrocarbon. What type of hydrocarbon? Can you see the double bond here? That means this is unsaturated hydrocarbon, which belongs to alkene. And when come to compound K, we can see is non-hydrocarbon because consists of O. So due to the presence of OH, we know this is hydroxyl. So the family name will be alcohol. So this is how you have to go about in answering the questions on homologous series and function. Okay, now we're going to look at the naming of the compound for each homologous series. But before we further up on the naming of the compounds, what you have to do is you must know the root name according to the number of carbons. This is very important, students. You have to memorize. Okay, like I think only the first four you have to memorize. From number 5 onwards is similar to your polygon derivations. Like if it's a 5 angle, we call it as a pent or polygon, right? 6 is X. 7 is half, 8 oct, 9 non, and 10 is dec. Only the first 4 you have to memorize. Okay. If the number of carbon is 1, the derivation we use is met. If it's 2, at. If 3, prop, and 4 is built. So this is very important. Students have to memorize based on the number of carbon. And then another one you have to know about the suffix, that means the ending name of each compound based on their homologous series. If the compound belongs to alkane, then the ending will carry the family name, which is ANE. If it's alkene, ENE. Alkyne will be in YNE. For alcohol, okay, for alcohol, we will derive the name of the alcohol from the respective alkene. So if it's alkene is ANE, for alcohol we just take out the E, substitute with OL. And carboxylic acid also comes from the respective alkene. So same thing, we take out the E, we substitute with OIC acid and ester. Okay, now I show you how to go about on the naming of the compound. Okay, now let's say we do for alkene now. Like alkene, if the carbon is 1, then the prefix will be met, ending will be in, methane. Okay, if it's the same thing goes for alkene, then if let's say it's carbon 3 for example, so now prop is the root name even based on the number of carbon, and ENE will be the ending. Okay, so now for alkene, there's another things you have to remember on the naming the compound. Carbon 1 to 3, carbon 2 to 3 have no problem because there's no GPS location involved. Okay, let's look at carbon 4. When it comes to carbon 4, when you want to draw the structure, let's say you align the carbons, 4 carbons in line, and the rules for alkene, one of it must be double bond, so you just put up your double bond between the carbons. The rest of the carbon will be single bond, and each carbon must have 4 bonds. Please count and place the bonds, and the empty bond fill in with hydrogen. Okay, this will be the structural formula for carbon 4 for alkene. Now we want to do the naming for carbon 4. So what will differ from the original one? We look at it like I told you, there's a root name given based on the number of carbon, and the ending will be the name of the family, right? But starting from carbon 4 for alkene, what happens is you have to specify the location of the carbon double bond. So now we have to do the numbering. When you do the numbering, make sure you number the double bond location small number. So now we start over here 1, 2, 3, 4. So the location of the double bond is between carbon 1 and 2, right? So you have to give the small number, you take the 1. So that 1 will be the GPS location for the double bond in this compound. So how we go on naming the compound is, because contains 4 carbon, we give build, and then ending going to be in because it belongs to alkene double bond. And then where's the location? The location is between 1 and 2, so we take the small number 1. So the name of the compound now going to be build 1E. Okay, so alkene, and same goes for alkyne also. Let's say I do for alkyne now. C4. So I'm placing the 4 carbons in row, and let's say I want to put up here the triple bond. The rest of the carbon I place it with single bond, and make sure each carbon have 4 bonds. Okay, now this will be the structural formula for the carbon form in alkyne. So now how do I go about the naming? Before we do the naming, we have to do the numbering for the GPS location of the triple bond here. So 1, 2, 3, 4. Total number of carbon is 4, so the root name going to be build. And the location of the triple bond is between 2 and 3, so we take the smallest number 2 in. So this structure is known as build 2E. And that is okay. Now let's go for alcohol. For alcohol, starting from carbon 3, okay, let's say I draw the structure for carbon 3. I have 4 carbons in line, link each carbon with single bond, and I have to place the functional group OH. Let's say I put it up here, OH, the rest will filled in with hydrogens. So now we have to do the numbering as well, and make sure the location of the functional group, we have to give the smallest number, so the numbering will start from this end, 1, 2, 3. So same concept for alcohol, we have to specify the location of the OH, which is the GPS location for this functional group, will determine based on the number of carbon where the OH is attached to. So the maximum number of carbon in this longest carbon chain is 3. If it's 3, it's going to be prop. Okay, and the ending okay, got 3. So if it's the respective alkane, it's going to be propane, isn't it? So what we do is we just take out the E out from the propane, so it will be propan dash OL, or, and where's the location of the OH at carbon 1, so it's going to be propan 1 or. So remember, for the name of the alcohol, we have to derive it from the respective alkane. So only the E is going to substitute with the GPS location followed by the OL, the ending of alcohol. Whereas for carboxylic acid, okay, let's say I'm doing it for carbon 2. So now how we go about it, I always will advise my students to draw the tail. The tail, what I mean is the functional group. So we will put up the end, the tail, functional group. Then total must have 2 carbons. Remember, here already have 1, so we add another 1 more. Then fill in the blank for the bond for the carbon, maximum 4. And this empty space fill in with hydrogen. So completed the structural formula for carbon 2 for carboxylic acid. So now how we go about the name is same thing. If 2 carbons, alkene will be at in, right? So what we do, we take out the E and substitute with OIC acid. So For carboxylic acid, is going to be known as ethanoic acid. Okay, so this is the naming of the compounds for alkene, alkyne, alkyne, alcohol, and carboxylic acid. So remember, for alkene it's a simple rules because you have only two parts involved. There's only two parts involved. One is based on the number of carbon, another one is the ending group. When it comes to alkene, carbon 2 to 3, same concept. You have the number of carbons name followed by the ending of the name of the family. But starting from carbon 4, you have three portions of the name. First part will be based on the number of carbons will be given, and the middle part will be the GPS location of double bond. Okay, this is for your own reference lah. And the ending will be the name of the family. Same goes for alkene. The same manner it works. But when it comes to alcohol and carboxylic acid, remember the name must derive from the respective alkene. Just take out the E out and substitute with OL for alcohol and OIC acid for carboxylic acid. Okay. Okay, so now it seems we have done on the naming just now. Let's try on these questions. So when you have this type of structure formula given in a very long chain, what I will advise is students try to count and find the longest carbon chain consists the largest number of carbon in it. So your counting must always choose from the n carbons. So you just do continuous counting. For example, let's say I'm taking from this carbon 1, 2, 3, 4, 5. One row. Another row I can go up 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, and is there any other alternative way I can go on to get the longest carbon chain? So let's say I'm taking this n of carbon to find the longest carbon chain. So 1, 2, 3, 4, 5, 6. So the longest carbon chain I obtained was 6. So consider this going to be the backbone of the compound. The backbone of the compound, try to find the longest carbon chain. Okay, so now upon you find the longest carbon chain, then what you have to do is you have to do a numbering for each carbons in the longest carbon chain. So when you are doing the numbering for the longest carbon chain, right now this is an alkene for sure, we know because all are single bonds, right? So when it comes to alkene families, we do the numbering based on if there's any attached group to the compound. So right now we will see there's carbon had been left out, which is not included in the longest carbon chain. This is called as attached group. When you find CH3, yeah, this is attached group. Each name of it is known as methyl. Okay, so right now I'm having two methyl groups attached to the longest carbon chain. So when you want to give the numbering for the longest carbon, make sure this attached group must have the smallest number. For example, let's say I'm doing the counting from here 1, 2, 3. So this is going to be the location GPS 3. For 5, this is going to be 5 and this is going to be 6, right? So let's say I'm doing the counting the other way around 1, 2. So here going to be 2, 3, 4. This is going to be the 4, 5, 6, right? So I have to give the smallest number for the attached group. So in that sense, I'm going to do the counting from here 1, 2, 3, 4, 5, 6. So the longest carbon chain is 6. So the basic name based on the number of carbon is going to be XA. Right? Okay, this is the alkene family. Remember, because all are single bonds, so I'm sure it's alkene. So because it consists of 6 carbon, hex, and family name in, so the basic name given for the longest carbon chain is hexane. Now, beside the longest carbon chain, as we identified just now, there are two attached groups. Where is the location? 2 and 4. So you have to specify the location 2, 4. If got only one, we just say methyl. But if it's more than one group, attached group over there, then you have to use the prefix like di. If it's 3, you have to use tri. If it's 4, we will say tetra. So right now it's 2, so we mention it as dimethyl X. So with that, you should be able to find the longest carbon chain. Once you have identified the longest carbon chain, I think you already got the answer option. So these are the things you have to bear in your mind when you are doing the naming for the structural formulas given to you. First thing, do the counting from end to end of the carbons. Find the longest carbon chain. Then you please draw the backbones like what I've done in the red color paper here, pen here. And then consider about the numbering. When you're doing the numbering, please consider on the location. Make sure you obtain the smallest number. And with that, I think you should be able to do the naming completely. Okay, now let's try the same method here. Okay, the moment I see my structural formula here, I can see there's a functional group in it. What's a functional group I can identify is the double bond. So in that case, my longest carbon chain must consist this double bond, this functional group. So find the longest carbon chain. 1, 2, 3, 4. 1, 2, 3, 4. Okay, anyhow, rather I'm going to get 4. So let's say I make this to be my longest carbon chain. So same thing, my numbering, am I going to start from this end or the other end? I have to look at the attached group. Right now, this structure have the attached group over here. So hence, I'm starting the longest carbon chain numbering over here. 1, 2, 3, 4. Okay, so that the attached group have the small number. And then we can start up on naming the basic carbon chain first. The longest carbon chain consists of 4, so the prefix will be but. And remember, this is double bond belongs to alkene, and I told you already, if it's 4, we have to specify the location of the double bond. Double bond location is 2 in, right? And where's the location of the attached group? At carbon number 2. So it's going to be 2 methyl but 2. Okay, now let's try one more. Same concept. You have to look carefully. All the elements involved are carbon and hydrogen. That means it's hydrocarbon. So if it's hydrocarbon, it's either going to be alkene or alkyne. So what you have to do is look at the interlink between the carbons. So can you find the double bond here? So that means this link should be included in the longest carbon chain. So let's say do the counting, find the longest carbon chain now. So I'll be taking this as the longest carbon chain because it consists of most the number of carbon. And then I have to consider on the numbering. Where should I start my numbering? Am I going to do from top to bottom or bottom to top? So anyhow, rather it's going to be 3, but remember if the double bond is here, so double bond must have the smallest number. So I must start my numbering over here. 1, 2, 3, 4, 5. So 5 will be pentene because of a double bond. And then we have to specify the location of the double bond. The location of the double bond now is pent 1, right? Okay, and then we do have an attached group at carbon number 3. So it's going to be 3 methyl pent 1 in. Okay, now this is for structure questions. Sometimes they'll give you a structural formula and they will ask you to. So this is an example of question for your paper 2 structure. So right now they have said that compound K can be produced from compound J under high temperature and pressure. So now you are required to name the compound K. So let's look at compound K, and the moment we see there's an O there, is no longer hydrocarbon, it become non-hydrocarbon. So definitely what you must come to your mind is no more alkene or alkyne. This is going to be alcohol, carboxylic acid or ester. Look at the functional group OH, that means it's going to be alcohol. right? So what's the name of the alcohol? You have to keep the numbering for the longest carbon chain. 1, 2, 3, 4. So 4 will be butane. Remember, E we take out and we specify the location. Ending will be all. The location here is 2. So butane 2-ol. Okay, we have finished on identifying the homologous series, functional group, naming the compound, drawing the structure, and so on. So now we are moving to the chemical properties. So the very important is you must be aware and you must know on the condition required for each reaction and the name of the reaction and the product formed. Okay, among the homologous series, alkene has the most chemical reactions because due to the presence of double bond. Okay, it undergoes addition reactions, and among the chemical reactions of alkene, the very famous one you have to focus to is here, this one. Okay, this process is called hydration. And one more famous one is the second reaction, which is called hydrogenation. Students always get confused between these two because it sounds similar. Okay, I want to give you a hint here. Remember, hydration is hydrate, water. That means adding water. Hydrogenation, you can see the full word of hydrogen. That means we are adding hydrogen to the compound. Okay, just a clue for you. Now, during the process of hydration, when you want to add water molecules into alkene compound, you need a specific condition. Okay, the condition required 300 degrees Celsius, 60 atmosphere pressure, and you are required to use concentrated phosphoric acid. Now, these three conditions, please memorize. Now, what will happen is when you add the water molecules, so the alkene will form their respective alcohol. Whereas for hydrogenation, to add up the hydrogen atoms to the double bonds, you need a catalyst which are known as nickel, and the temperature required is 180 degrees Celsius. With that, the reaction will be performed and form their respective alkene. And you must have a strong idea about how the reaction happens at double bond for alkene. Remember, students, always the reaction will occur at the functional group, especially for alkene. Now is a double bond, right? So during the reaction, what happens is the double bond will break up. When the double bond breaks up, so during the reaction, what will happen is the double bond will break up. Okay, when the double bond breaks up, it will form the respective single bonds between the carbons. So right now, okay, they will break up and form two single bonds. So whatever you are going to add in will come and stick here. So during the hydration, I'm adding water. So water will form one hydrogen atom and another one is OH. So one side the OH will go and stick, the other side will be hydrogen. So based on that, we will name the alcohol based on the GPS location of the alcohol. We specify it. Okay. Same goes for hydrogenation. For hydrogenation, we're going to add both with hydrogen. So both also will be H. If you're going to add bromine, then both places will be added with Br. Okay, so remember the double bonds forms between the two carbons. So when it breaks up upward or downward only. So each carbon will have the substituent element that we are adding to it. Okay, now that's for alkene. Other than that, you also must know if I'm adding hydrogen bromide or bromine water. And another famous one is about addition polymerization. Okay. Regarding addition polymerization, students, you must know that we will add up a few number of monomers of alkene, so they will form the interlink between them. Due to addition polymerization, they will form the long chain of their polymers. So what you do is just open up the double bond sideways and put it in the bracket to get their respective monomers. Okay, that's about alkene. So now we are moving to alcohol. Alcohol have four chemical reactions. The very important one is dehydration and oxidation. You must know esterification is a complementary reaction between carboxylic acid and alcohol, which forms the esterification. So esterification I'll explain to you later. So now we're going to look at the next reactions. First, okay, combustion. Remember, alkene, alkyne, and even alcohol, they will combust, they will burn and form carbon dioxide and water. So what's the difference between alkene to alcohol is alkene will burn with yellow flame, whereas alcohol will burn with blue flame because it's a clean fuel, does not produce any pollution, and it doesn't produce no soot. No soot will be produced. So that's the reason why alcohol is suitable to be used as a clean fuel. Okay, because it's not forming any soot, does not cause any pollution. So that's the reason why alcohol are known as a clean fuel and suitable to be used as a fuel in many things. Okay, so what you should know is all the carbon compounds, when they burn, they will form carbon dioxide and water. You balance out based on the valence chemical. Okay, the next reaction of alcohol you should know is alcohol will be oxidized and form their respective carboxylic acid. Like now, when we use ethanol, ethanol will be oxidized. Okay, very important when you're writing your balanced chemical equation for oxidation, you will put the O in the bracket. Remember, not O2. Okay, the 2 will be balanced out in front and it will form the respective. If I'm using ethanol, it will form ethanoic acid. Propanol will form propanoic acid. And you should know the observation for oxidation because of the formation of alcohol to their respective carboxylic acid. So what will happen when you test with potassium manganate 7, it will be decolorized. If you use a potassium dichromate 6 solution, then the color will change from orange to green. So observation on this oxidation reaction is quite famous for the question. So you should know, and other than that, you should be able to write the balanced chemical equation. Okay, and the very famous reaction for alcohols is dehydration, because this is not only famous for structure, it might become out for your essay. So the very important thing what you should know about dehydration is the apparatus setup. Okay, it's a very common question will come out for drawing. Usually students will make mistakes at the part of label. So make sure you have the middle section is the porcelain chips, and make sure you place a stopper. When you're placing the stopper, make sure you place it half in, half out, and the delivery tube will be going to the mouth of the test tube to collect the gas using a water displacement method. And you must show the heat. It should be heated up. Okay, so we will heat the porcelain chip strongly, and then we will go and warm up the glass wool soaked with ethanol. So that what's the purpose of the porcelain chips here? It become the drying agent. It will remove the water from the respective alcohol. So during dehydration, what really happens, you should understand, the alcohol will be dry up. The water content will be removed from the alcohol. So when alcohol loses water molecules, it will form their respective alkene. If I use ethanol, it will become ethene. Propanol, propene. Okay. So how do I test on the gas collector? So alkene, we can use potassium manganate 7 or bromine water. Both will be decolorized. Because one of the reaction of alkene, it can decolorizes the bromine water, brown bromine water, and also it can decolorizes the acidified potassium manganate 7. That two region can be used to confirm the presence of alkene at the end of dehydration. So before writing the equation, drawing the setup, make sure you know the procedure how to carry out the addition, because it might be questioned for your essay part. Okay, now we're going to look at the chemical properties or chemical reaction of carboxylic acid. Okay, for information, you should be able to link the reaction between each homologous series. Now, carboxylic acid is actually originated from alcohol through the process of oxidation, as what I explained to you just now. Now, how about carboxylic acid? Carboxylic acid, you don't need to memorize each reaction. You must know carboxylic acid is actually acid, right? So it will have the chemical properties same as acid. Like what we have studied earlier, acid can react with alkali, will form salt and water. So same goes for carboxylic acid. It can react with alkali and form salt and water. It also can react with the metal oxides and form salt and water. If you react with metal, it will form salt and hydrogen. It also can react with metal carbonate, form salt, carbon dioxide and water. So in generally what I can conclude here, carboxylic acid reactions you don't need to fear about, because it shows a similar chemical properties or chemical reaction as acid. That's what we have studied earlier in acid, base and salt. Okay, so now let's try on the questions. We have learned on the chemical reactions of homologous series. So let's go and try now on this question. So students, how to do this question now? What you have to do is look carefully. They say that compound G is used and reacted with bromine in tetrachloromethane, and then you can see it here. Can you see there's a Br? That means previously there would be exist a double bond between them, right? Addition reaction. So which of the following is a compound G? So now these two had been added up newly after the reaction. So initially there's a double bond between them. So as usual, you know, we have to name the compound. So the former compound G should be the homologous series of alkene. So 1, 2, 3, 4. So most likely compound will be butene. Okay, so you have to go backward and find out the name of the compound. So the very important here, you should be able to identify which part the reaction occurs. Okay, now let's look at this question. Propene react with chlorine. So when we know propene, okay, this is actually propene, double bond. So when propene react with chlorine, so we know propene will have 3 carbons and in between they have the double bond. So most likely carbon 1 and 2, because it comes either way around, so that 2 carbons, subsequent 2 carbons will be added up with Cl. So if you look at A, the Cl is added to the same carbons, so which is wrong concept. Now if you look at B, this is the 2 carbons side by side, can be added each with Cl. Okay, possibilities could be the answer, but anyhow let's check on C. There are too many places the Cl had been added, impossible. We have only 2 Cl, so 2 places only will be added up. And here there's only 1 Cl. Perhaps here got 2 Cl. So answer is B. Okay, this is also quite famous one, will be question on polymers. So how do you determine the monomer of this? So what you should do? Okay, so how to go about it? So students, what you have to do is go and look where is the polar repetition of the structure. As you can see here, on H, here is carbon, but here got the polar CH3H, CH3H, CH3H. So we go for the shortest polar. We can see this is the first polar, second and third. So this is the first structure. So when this is the first structure, most likely the double bond exists between these 2 carbons. That's the monomer. Because formation of polymer is the double bond will be unwound sideways and form the long connecting links. So find for the monomer of this. Not this. So CH3, but here the double bond is missing. So when we are talking about monomer for polymer, the compulsory must have double bond. Okay, so the answer is C. Okay, now we are going other way around. So which of the following is the monomer of the polymer? So it works the same way, what I taught you. You just take the sideways one and put it in the center to form the double bond, because during the formation of the long chain, they will open up sideways. The double bond open up sideways and form the interlinks. So when they want to form polymer to monomer, you close it up. So when you close it up, so how the structure looks like? Here will be H, here H, here C double bond, HCl. So what's the best answer you could see? Yes, the answer is B. Okay, now let's look at this question. They say that ethanol had been added with a piece of porcelain and it formed ethene and water. So the moment you see, what you should know is, now we are doing conversion alcohol to alkene. Alcohol become alkene because of removal of water. So what process is that? Removal of water. Water, I told you already just now, hydration. So removal, dehydration. And then now, this is a setup, right, for dehydration. So they are request you to find the characteristic of gas T. So same thing, what you should know is we are converting the alcohol to their respective alkene. So now I'm using ethanol. So ethanol is going to form ethene. So what's the reaction of ethene? Ethene, as I told you just now, they can decolorize two regions. It's either acidified potassium N7 or bromine water. So the best answer that we can get here is decolorized bromine water. Okay, now besides knowing the individual reaction, we also should know the conversions. Now, when you get this type of interchange, what you have to do is do analysis first. You must recognize ethene is alkene, which have the double bond. Now changing to alkene. Alkene will become alkene by adding hydrogen, correct? So it will form hydrogenation, and then through addition reactions. Now, alkene also form carbon dioxide and water. This must be combustion. These are the ideas must be in your mind based on the reaction you have studied. And the moment you see polythene, this is polymer. That means the process will be polymerization. Can you see that? Okay. So these are the important reactions that you should know. That is what I have gone through with you earlier. So try to embrace the reactions which I have explained to you just now. With that, I think it shouldn't be a problem for you to do it. So we go for reaction 1. We don't have the option of hydrogenation, but we know hydrogenation is an addition reaction. So we have the option for the answer of addition. So either B or C. Now let's go and check for reaction 2, which is combustion. Okay, C. And then reaction 3 is polymerization. So hence our answer will be C. Okay, now we're going to look at a very important chemical reaction in the carbon compound, which is known as esterification. Esterification is a reaction between alcohol and carboxylic acid, which forms the new homologous series of ester. Now, what you have to know about esterification is, at the end of the day, the product formed will be a ester, and you must know the characteristic of ester. Ester is actually have a very sweet, pleasant smell, and is less dense than water, so it will float on the water. So these are the physical properties which you should mention when it's questionable in your paper too. Now, okay, now I'm going to show you about the reaction of esterification. As I told you just now, esterification is a reaction between carboxylic acid react with the respective alcohol. They form ester and water, and this process occurs with the catalyst concentrated sulfuric acid. Okay, so now let's say, for example, I'm using butanoic acid, so C3H7COOH. I'm going to react it with ethanol, C2H5OH. So how do I find the molecular formula of the ester? Students, remember, always take out H from carboxylic acid, OH from alcohol. These two are going to combine and form the water. And the remainder, always for ester, take the part of carboxylic acid first. Okay, ester, the front part will be carboxylic acid. So you just shift this here, C3H7COO, okay, and then you combine it with the alcohol part, C2H5. That's how we derive the molecular formula of the ester. So remember, C double bond O, that's the functional group of ester. So you want to draw the structure. How you go about it? You start from the bridge. I always call this as a bridge because that's the bridge act upon to connect the carboxylic acid structure to the alcohol. So always you start to draw the bridge first. C double bond O, O. Okay. Now, how many carbons before the bridge? 3, right? You align 3 carbons before it. Okay, how many carbons at the back of the bridge? There are 2. So you continue another 2 more carbons at the back. Then you place 4 bonds for each carbon. Fill in the blank with hydrogen. You are placing the bond only for carbon now. Don't go and place the bond to oxygen. Okay, the bond for the oxygen comes in the bridge really, that's it. Okay, now this is the structural formula for the ester. Now how do I go on the naming the structure? Remember, as we know that this whole thing is a carboxylic acid, right? So carboxylic acid, the name of this carboxylic acid is butanoic acid, right? And then this is the part of alcohol, which is ethanol. Naming of ester, you do crossing. You bring the name of alcohol in front. Structure wise, carboxylic acid, but naming we will do a crossing. So don't remember both, you'll get confused. So you only remember the structure. Then structure wise, carboxylic acid structure comes first, followed by alcohol. So then you do the crossing. The name of the alcohol now become alkyl group. So ethanol become ethyl. Okay, and the carboxylic acid part will change. The OIC acid will change to OATE. So we take out the OIC acid, we put OATE. So it's going to be ethyl butanoate. So this is the name of the ester. So when we talk about esterification, students, again you must be able to write the balanced chemical equation. So I taught you really just now. If you're able to derive the correct molecular formula of the carboxylic acid and alcohol, I think it shouldn't be a problem for you to do for ester, because you just take out the H from carboxylic acid, OH from the alcohol, then you merge it. Remember, carboxylic acid part comes first, alcohol at the back. Okay, and then you take the bridge, the C double bond, you draw first, then you align the carbon front and back and place 4 bonds for each carbon. With that, you're completing the structure for ester. When coming to the naming, remember the name of the carboxylic acid must take out the OIC acid, substitute with OATE. And alcohol, you take out the alcohol name, change it to alkyl name. Okay, so what we do is we take the prefix F, but we don't do the ending part, we change to YL. If it's ethanol, ethyl, propanol, propyl, butanol would become butyl. Okay, then the naming wise it will be crossword. So name of the alcohol become to alkyl, carboxylic acid become to the back, OATE. So I hope you understand about esterification. So now let's try on questions on esterification. Okay, now let's look at this question now. So are you able to determine the homologous series? So just now I told you already, right? Homologous series means they want the name of the compound family. So look at this, COOH, carboxylic acid, OH, alcohol. So carboxylic acid react with alcohol, going to be ester. Now, which of the following are needed to produce the following compound? So students, as you can see here, can you see the bridge or not? Are you able to view the bridge? Yes. So right after the bridge, you have to do the splitting. Okay. Now, right after the bridge, please do the splitting, because this whole thing going to be the carboxylic acid part, at the back going to be the alcohol part. So now let's count how many carbons there. 1, 2, 3, 4. If it's 4, it's going to be butanoic acid. If you're not sure, you better write down first, so that you won't do a mistake when you're filling it out. Okay, and here alcohol got 2 carbons, that's going to be ethanol. So now let's go and choose the respective alcohol. The alcohol should be ethanol. It's going to be B or C, but based on carboxylic acid, it's butanoic acid, so the answer is B. Okay, again, which of the following alcohol react with propanoic acid to produce the above compound? So again, students, identify the bridge for the ester. Then right after the ester, do the splitting. So they say propanoic acid, of course, 3 carbon propanoic acid. So this is the alcohol part. Alcohol contains how many carbon? 2 carbons. So the 2 carbons should be ethanol, right? So now go and find for the structure of ethanol. The rules for ethanol must have 2 carbons. Okay, so the answer is B. Now let's look at this. They have given you the name, so now they want you to draw the structural formula. So if you are not good at straight away drawing the structural formula, my advice is you draw individual structural formula first. Propanoic acid, you start from the tail part for carboxylic acid, C double bond O, OH, that's the tail part, right? So propanoic acid must have 3 carbons, here got 1, so you add up another 2 more, place 4 bonds for hydrogens, 4 bonds for the carbons, fill in the blank with hydrogen. Okay, this is the propanoic acid. And let's draw for ethanol. Ethanol will have 2 carbons, and one side will be the OH. The others will be filled with hydrogen. Okay, so now follow the rules I've taught you. What you have to do is you cancel off H from carboxylic acid, OH from alcohol. Then you merge them. So when you're merging them, remember, this is going to be your bridge. So go and identify all your bridge in the structure given. Before bridge, you have 2 carbons. Come to check which one you have 2 carbons. So this one you have 2 carbons, right? And the others not. So most likely by looking at it, you already know it's B. By hanging out rather, look at the alcohol also is 2. So the best answer is B. Okay, this also works the same way. So they put it other way around. If you find comfortable to put carboxylic acid first, then you draw it in such a way. You cancel off H and OH. So we go for this first. C double bond O, O, we draw the bridge first. Front got 1 carbon, fill in the blank with hydrogen. Okay, this is the front structure of it. At the back, we add up another 3 more carbons. 1, 2, 3, fill in the blank with hydrogens. Okay. And then please go and find for the optional answer that you have. So front must be CH3. Then you should have C double bond O. So here will be CH2, CH2, and then CH3. So the best answer that you get upon you completing the analysis is okay, the answer will be B. Now, same thing, propanolic acid, ethanol, and then you have to find the molecular formula of Q. So how to do that? You please do the propanolic acid first. So we know propanolic acid, COOH. Remember at the back you must start with COH. So front will be your minus of 1. Propanoic, remember prop 3. So you already have 1. So you start with substitute with 2. So C2H5 COOH and ethanol C2H5OH. So cut off the H and the OH. So merge out. When you merge them, you'll get C2H5 COO C2H5. So the answer is C. Now what's the name of this ester molecules? Same thing. I think this one, the diagram have some problem with double bond. The double bond usually should be here. Okay, not this. Now how to do it? As I have taught you, after the bridge, cut it off. This is the bridge, right? After the bridge, cut it off. This should be the carboxylic acid. So how many carbons there? 1, 2, 3. So 3 will be propanoic acid. How many carbons at the back? 1, 2, 3, 4. So there should be butanol, right? Okay. So when you do the crossing, butanol become butyl. Okay. That's going to be butyl. Okay. And OIC acid, you cancel it. They're going to substitute with OAT. So it's going to be propanoate. So the name of the ester will be butyl propanoate. So we are coming to the end of today's lesson. I hope that what I taught you would be helpful for you to do your preparation for this chapter. And my final word, for your essay part, please get prepared for esterification process. So make sure you know how to conduct esterification according to the correct procedure. And besides esterification, please focus also on dehydration experiments. Okay, that's all. Thank you, students. Good luck. See you all in next lesson. Bye.